Today, we're working on a Toyota Venza with a serious brake system problem. The vehicle has multiple DDCs, including C052F14, C142719, and C060962. The first two codes are directly related to the ABS pump motor and the brake actuator assembly. But the third code is related to the electronic parking brake. So the big question is the EPB actually defective? Or is C060962 simply a secondary fault caused by the main ABS problem? In this video, we're going to follow Toyota's repair procedure from diagnosis all the way through brake actuator replacement, brake fluid bleeding, initialization, and final confirmation. Let's start with the DDCs. 055, DDC C052F14. The first code is C052F14. Toyota defines this code as ABS pump motor supply voltage circuit short to ground or open. In other words, the skid control ECU has detected an abnormal condition in the electrical supply circuit of the ABS pump motor. According to the repair manual, one detection condition occurs when the ABS pump motor is switched off, but approximately 0.6 volts or more is still detected at the pump motor for 0.48 seconds or longer. Another detection condition occurs when the voltage supplied through the ABS motor relay is below 5 volts for 0.15 seconds or longer. This is an important point. C052F14 does not automatically mean that the ABS pump itself is defective. Before replacing the brake actuator, we need to verify the battery voltage, power supply, ground, fuses, wiring, connectors, and the motor circuit. 205, DDC C142719. The second major code is C142719. Toyota defines this as ABS pump motor circuit current above threshold. This means the system has detected excessive current in the ABS pump motor circuit. When the ABS motor relay is operating, the skid control ECU monitors the motor circuit. If the current becomes higher than the specified threshold, or if a short circuit is detected in the pump motor drive circuit for the specified time, C142719 can be stored. This is why C052F14 and C142719 together are very important. When both codes are present, I would not immediately install a new brake actuator. First, I would verify the electrical system. Check the battery. Check the ABS power supply. Check the ground. Check the fuses. Check the connectors and terminals. Then check the wiring for an open circuit or short circuit. If all of these tests are good, the brake actuator assembly becomes the main suspect. 315. Understanding the brake actuator. Before removing the component, we need to understand what Toyota calls the brake actuator assembly. Many people simply call this component the ABS pump. But technically, it is much more than a pump. The brake actuator assembly contains the hydraulic control unit and important electronic components of the braking system. The ABS motor relay is built into the brake actuator assembly. When the vehicle activates ABS, traction control, VSC, brake hold, or brake assist, the skid control ECU commands the ABS motor relay. The relay then operates the ABS pump motor. So when we have an electrical fault involving the ABS pump motor, the diagnosis can lead directly back to the brake actuator assembly. This is why the Toyota repair manual lists the skid control ECU, which is integrated with the brake actuator assembly, as the trouble area for these DDCs. 410. Check the 12-volt battery. Before doing any major diagnosis, Toyota gives us a very important instruction. Check the auxiliary battery voltage. For a 12-volt system, the specified range shown in the repair procedure is approximately 11 to 14 volts. If the battery voltage is below 11 volts, Toyota instructs us to recharge or replace the battery before continuing with the diagnosis. This step may look simple, but it is extremely important. A weak battery or low system voltage can create abnormal electronic brake system DDCs. So don't replace an expensive brake actuator before confirming that the vehicle has a stable power supply. After checking the battery, we move on to the DDC and freeze frame data. 5 o'clock, DDC and freeze frame check. The next step is to confirm the customer's complaint and check the stored DDCs. If possible, save the freeze frame information before clearing anything. Freeze frame data can tell us what the vehicle was doing when the fault was detected. We should also perform a visual inspection. Check the wiring harnesses. Check the connectors. Check the fuses. Look for damaged wires, loose terminals, corrosion, water intrusion, or signs of previous repairs. Toyota's diagnostic flow is very clear. First, confirm the symptom. Then identify the DDC. Then identify the suspected circuit or component. And only after that should we perform the detailed circuit or component inspection. This prevents unnecessary parts replacement. 555, C060962 and the EPB. Now let's talk about the third code, C060962. Toyota defines this code as electric parking brake switch signal compare failure. At first, this looks like a completely separate EPB problem. But this is where understanding the Toyota brake control system becomes important. The electronic parking brake communicates with the brake control system through the skid control ECU. If the brake actuator has a serious internal or electrical fault, the system may not correctly process or compare the EPB switch signal. As a result, C060962 can appear together with the primary ABS DDCs. This means we should not immediately replace the EPB switch just because C060962 is stored. First, repair the primary ABS or brake actuator problem. Then clear the DDCs and perform the required initialization and confirmation procedures. If C060962 disappears and does not return, there may be no separate EPB component failure. However, if C060962 returns after the ABS problem has been completely repaired, then it needs to be diagnosed separately. 7 o'clock, brake actuator removal. Now let's move on to the physical repair. Before removing the brake actuator, make sure the vehicle is safely supported and the brake system is protected from contamination. The repair procedure begins with draining or removing the brake fluid as required. Be extremely careful with brake fluid. If brake fluid gets onto a painted surface, wash it off immediately. Next, we need to disconnect the electrical connector from the brake actuator. Release the connector lock lever carefully. Then disconnect the connector. Do not force the connector. And make sure no brake fluid enters the electrical connector. Brake fluid contamination can damage electrical terminals and create additional faults. 7:45. Disconnect the brake lines. Next, we disconnect the brake lines. There are multiple brake lines connected to the actuator, so identification is extremely important. Before removing them, mark their locations or document the routing with photographs. This will prevent incorrect installation during reassembly. Use the correct flare nut or union nut wrench. Do not use an ordinary open-end wrench if you can avoid it. A damaged flare nut can become extremely difficult to remove. Also protect the surrounding components from brake fluid. Once the brake lines are disconnected, protect the open ports and lines from contamination. 8:35. Remove the actuator. Now we can remove the mounting hardware securing the brake actuator assembly. Remove the specified nuts and bolts and carefully take the actuator and bracket out of the vehicle. Once the assembly is removed, separate the actuator from its bracket according to the Toyota procedure. At this point, the old brake actuator is completely removed. Before installing the replacement unit, compare the old and new actuators. Check the connectors. Check the hydraulic ports. Check the mounting points. Make sure the replacement part is correct for the exact vehicle configuration. 915. Install the new brake actuator. Now we install the replacement brake actuator. Make sure the mounting surfaces are clean. Position the actuator correctly on the bracket. Tighten the mounting hardware using the specified torque. For this Venza procedure, the actuator to bracket fasteners are tightened to the specified torque, and the actuator assembly is then secured to the vehicle. The brake line connections also have specific torque specifications. Do not guess these values. Always use a calibrated torque wrench and the specification for the exact model and configuration. This is a hydraulic brake system, so correct torque is critical. Another important point from Toyota: do not remove the protective plugs from the replacement actuator ports before you are ready to connect the brake lines. And never carry or lift the actuator by its electrical connector. 10 o'clock. Brake fluid bleeding. Once the actuator and brake lines are installed, the brake system must be properly bled. This step is extremely important. Any air trapped inside the hydraulic system can cause a soft brake pedal and incorrect brake pressure. Make sure the brake fluid reservoir remains at the correct level throughout the procedure. Bleed the system according to Toyota's specified procedure for this vehicle. After bleeding, carefully inspect every brake line connection. There must be no brake fluid leakage. The brake pedal should also have the correct feel before the vehicle is returned to service. 10:45. Techstream initialization. Now comes one of the most important steps. Mechanical installation is not the end of the repair. Because this is an electronically controlled Toyota brake system, we need to use Techstream to perform the required inspections, initialization, learning, or calibration procedures for the specific vehicle. After completing the required procedures, clear the stored DDCs. Then turn the vehicle off and back on. Perform another complete health check. We want to confirm that C052F14 and C142719 do not return. We also need to check the EPB system. 11:25. EPB confirmation. Now operate the electronic parking brake. Use Techstream to monitor the EPB switch data. The switch status should change correctly when the parking brake is applied and released. If C060962 does not return after the ABS problem has been repaired, this strongly suggests that the original EPB DDC was associated with the primary brake system fault. But if C060962 returns immediately, we need to continue with a separate EPB diagnosis. At that point, check the EPB switch, wiring, connectors, terminals, power supply, and the skid control ECU. Never assume that every DDC appearing at the same time has the same root cause. 12:05. Final confirmation. After completing the repair, we perform the final confirmation test. Clear all DDCs. Check the ABS system. Check VSC and traction control. Check the electronic parking brake. Verify the brake pedal. Check for hydraulic leaks. Then perform a C142719 together on a Toyota Venza. Don't immediately replace the ABS pump. Follow the diagnostic process. Check battery voltage. Check power and ground. Check the wiring and connectors. Then evaluate the brake actuator assembly. And if C060962 appears at the same time, don't automatically replace the EPB switch. Repair diagnostic approach. If you found this video useful, subscribe to Mechanic 1 SHO for more professional Toyota and Lexus diagnostic and repair videos. Thanks for watching, and I'll see you in the next one.